Hi, this is Ajnad. Today we are discussing about MongoDB and how to work with it and the other stuff to discuss about. Let's hit the like button and subscribe our channel for more information. Let we jump into our SQL concept. Firstly, what is we need to discuss about what is the difference between the SQL and no SQL to gather information about MongoDB. Firstly, we see about the SQL. Structural query language is structured database. It contains structural database. SQL databases are based on predefined schema. Data is stored in the tables, and each table has a fixed structure with specified columns and data types. It also using ACID transactions. SQL database follow ACID atomicity, consistency, isolation, durability properties. Ensuring a reliable transaction, this is crucial for application where data integrity is of utmost importance, such as financial applications. Scalability. Traditional SQL databases can scale vertically. However, scaling horizontally can be complex and costly. Complex queries. SQL database excel at handling complex queries involving multiple tables and relationships. They are suitable for application that requires intricate data manipulation and reporting. For example, MySQL, PostgreSQL, Oracle SQL Server, SQLite are some of the SQL database softwares. So now we jump into our topic now, NoSQL databases. Firstly, we need to see about the schemaless. NoSQL database are schemaless, meaning each entry in a NoSQL database can have a different fields. They are more flexible when it comes to handling unstructured or semi-structured data. Base transaction like NoSQL database often follow the basically available soft state eventual consistency model. While they sacrifice strict consistency for availability and partition tolerance, they are suitable for distributed system and can handle large amount of data and higher user goals. NoSQL databases are designed to easily scalable horizontally. They can handle large volumes of data and high traffic loads by adding more servers to the distributed networks. NoSQL databases are often simpler to design and manage, especially for use cases where the data model is evolving rapidly or the extract structure of the data is not known in advance. Types of NoSQL. NoSQL databases are categorized into document oriented like MongoDB, key value stores like Redis, column family stores like Apache Cassandra, and graph database like Neo4j. Each type has a specific use case and advantages. Choosing what is best to choose SQL or non-SQL. Let's see some of the points before we choose the SQL or non-SQL. Choose SQL if your application requires complex queries and transactions. You need a ACID compliance for data integrity. Your data structure is unlikely to change frequently. Choose NoSQL if your application requires horizontally scalable and can benefit for distributed fault tolerant systems. Your data is unstructured, semi-structured, or rapidly evolving structured. Your prioritized highly availability and can tolerate eventually consistency. It's important to note that the choice between SQL and non-SQL depends on the specific requirements and characteristics of the application being developed. Now we let's see what is MongoDB and the introduction to MongoDB in this topic. MongoDB is a popular open source NoSQL database management system that falls under the category of a documented oriented database. It is designed to handle unstructured or semi-structured data and is well suited for building modern, scalable, and flexible applications. MongoDB stores data in a JSON files like documents, making it easy to work with data in natural and innovative way. Key features of MongoDB. Some of the key features are schema flexibility, JSON-like documents, rich query language, horizontally scalability, and etc. Let me deeply dive into these topics. For schema flexibility is meaning documents is a collection do not needed to have a same structure. Fields can vary from document to document, giving developers the flexibility to evolve data model. The application requirements can change over time. JSON-like documents data is stored in a BSON binary JSON format which supports various data types including nested arrays and documents. BSON is both human readable and efficient for storage and data exchange. rich in query language. It provides a powerful and expressive query language, allowing developers to perform complex queries, filter, sort, aggregate data with ease. Queries can be also based on the values of embedded documents and arrays. Horizontal scalability. MongoDB is designed to scale horizontally across large clusters of community servers or cloud environments. This allows applications to handle a large volume of data and high traffic loads by adding more servers to the clusters. Automatic sorting. MongoDB supports automatic sorting, which means it is distributed data across the multiple machines without requiring application level changes. Sorting ensures that each shared portion of the data is stored on a separate server, enabling efficient data distribution and retrieval. High availability. MongoDB provides features like replica sets, which are a form of data redundancy. In a replica set, data is replicated across multiple servers, ensuring high availability and fault tolerance. If one server fails, another can automatically take over to prevent the downtime. In aggregation framework of MongoDB. Aggregation framework is a MongoDB. MongoDB include a powerful aggregation framework that allows developers to perform a transformation and computation operators on the server side. This framework is particularly useful for analytics and reporting. Geospatial indexing. MongoDB supports geospatial indexing and allowing the storage and querying of geospatial data like coordinates and shapes. This feature is valuable for applications that involves location-based services, community, and ecosystem. MongoDB has a large and active community of developers and contributors. Additionally, it offers official drivers for various programming languages, extensive documentation, and a rich ecosystem of tools in a library. MongoDB is commonly used in a wide range of applications, including content management system, e-commerce platform, or real-time analytics, mobile application, and IoT applications, where flexible data models and horizontal scalability are essential. Its ease of use, flexibility, and robust features make it a popular choice among developers and business for a modern application development. MongoDB future. MongoDB as a leading NoSQL database offers a variety of features that make it popular among the developers and organizations. Here's an overview of some key MongoDB features. Flexible schema. Flexible schema. MongoDB is a schemaless, allowing documents in the same location to have a different structure. That is particularly useful when dealing with the evolving or semi-structured data JSON-like documents. MongoDB supports dynamic queries on the documents using rich query language. Queries can be based on the fields, range, regular, and expression, even the values of nested arrays and documents indexing. MongoDB provides a powerful aggregation framework of data. It is used for computation operations, filtering, grouping, sorting, projection, enabling complex analytics and reporting tasks automatically sharding. MongoDB provides various security features including authentication, role-based access control, SLS, TLS, encryption for data transmission, and auditing. The features helps protect data and ensure the access. Schema validation. MongoDB allows developers to define and enforcement documentation validation rules. This feature ensures that the data inserted into the database meets specifically criteria, enhancing data integrity. Native JSON supports. MongoDB offers official drivers for the wide range of programming languages, extensive documents, and a vibrant community. Additionally, there are various tools and libraries available to support development, monitoring, administration tasks. These features, among others, make MongoDB as a versatile and a powerful choice for developers. MongoDB natively stores JSON-like documents, making it easy to work with the data modern application, especially those developed in JavaScript or other languages. It uses a rich ecosystem to develop the database for the applications. MongoDB also allows developers to define and enforcement document validation rules. These features ensures that data inserted into the database meets specific criteria, enhancing data integrity. Native JSON supports. These features among these make MongoDB a versatile and powerful choice of developer, allowing them to build a scalable, flexible, and high-performance application. And the fourth topic is replication and high availability. Replication and high availability are critical features in a database system to ensure data durability, fault tolerance, and uninterrupted services. MongoDB provides these capabilities through its supportive for replica sets, which are form of database replications. Firstly, we see about replica set basics. A replica set is a MongoDB in a MongoDB consists of multiple nodes, typically at least three, one primary node, two or more secondary nodes. The primary node is the only node that accepts or write operations. Secondary nodes replicate data from the primary and can serve need operations. Replica sets provide automatic failover. If the primary node goes down, one of the scenarios is automatically and quickly ejected as the new primary, ensuring and continuous services. Data replication. Data replication in a MongoDB involves the primary node sending and operation log OP log to its secondaries. Secondaries applies these operations in an asynchronous manner to stay up to date with the primary data. Replication is eventually consistent, meaning that while there might be a slightly delay between a data being written to the primary and being replicated to the secondaries, the system eventually converges to a consistent state. Election of failovers. Replica sets use election process to select a new primary node in the event of primary failures. Nodes communicate with each other through a voting process to determine which node should become new primary. Elections are automatic and typically happen within seconds, ensuring minimal downtime in case of primary node failures. Read scalability. Replica slates improve read scalability. While only the primary node handles writes, all nodes including secondaries can handle read operations. This allows distributing read traffic across the multiple nodes, enhancing performance for read heavy workloads. Data durability and fault tolerance in MongoDB. Replica sets improves data durability by ensuring that data is replicated and stored on multiple nodes. Even if one or more nodes fail, the remaining nodes can continue to serve read and write requests. Fault tolerance is achieved by having multiple copies of data distributed across different nodes and, if possible, different physical locations. Automatic recovery. MongoDB's replica sets features automatic resynchronization if a secondary node goes down or falls significantly behind in replication due to network issues. It can be automatically catch up once it's back online. Arbiters. This is a new topic across the database system. It is the unique topic and a unique advantage of the MongoDB. In replica sets, arbiters are nodes that participate in an election process but do not store a data. They help prevent split brain scenarios where two nodes believe they are the primary by providing on a odd number of nodes for voting. Replica sets in MongoDB are a robust solution for ensuring a high availability, data redundancy, fault tolerance. By developing replica sets across the different servers or cloud instances, MongoDB can provide a continuous service even in the face of hardware failures, network issues, or planned maintenance activities. Nextly, we see the topic about sharding and scaling. Sharding and scaling. Sharding and scaling in MongoDB primary involves horizontal scalability, which allows you to expand your database capacity and performance by adding more servers to the MongoDB clusters. MongoDB achieves horizontal scalability through the technique called sharding. Sharding basics. Sharding basics of the MongoDB, which listen this topic carefully to understand. This is a complexable topic to understand, and which is the one of the most important topic, which may be useful to crack your interviews. Sharding is the process of distributing data across the multiple machines. In MongoDB, sharding is done at the collection level. The sharded clusters consist of shards, config servers, and query routers. Threads are individual MongoDB instances that store a subset of a shared data. Config servers keep track of metadata about the cluster configuration, and Mongo's routers directs the client request to the appropriate threads. Key concepts: shared key, a field in the document used to determine how the data is distributed across the threads. Choosing an appropriate thread key is crucial for even data distributions. Chunks: the data in a threaded collection is divided into chunks. Each chunk represents a range of thread key values. Balancing: MongoDB automatically balances the distribution of the chunks across a thread to ensure even data distribution. Threading process. Now we deeply dive into the threading process. When you enable threading on a MongoDB collection, MongoDB divides data into chunks based on the shared key. These chunks are distributed across the available threads. As data grows, MongoDB automatically splits chunks that have exceeded a predefined size. Additionally, MongoDB can also merge chunks if they become too small, optimizing data distribution. Read and write operations. Query routers wrote read and write operation to the appropriate threads based on the shared key. This allows for parallel processing of queries, enhancing performance. Aggregation pipelines and secondary indexes can be leveraged efficiently, making complex queries faster and more scalable. Adding threads. To scale your MongoDB clusters, you can add more threads as your data and a query load increases. MongoDB will automatically rebalance the data across the new and existing threads. Data distribution and scalability. Sharding allows MongoDB to scale horizontally, providing an efficient way to store and manage large volumes of data. By adding more threads and properly choosing the thread key, you can achieve nearly the linear scalability, high availability, and failover. Each thread in a MongoDB can be deployed as a replica set, ensuring high availability and failover capabilities. If a primary thread node fails, one of the secondary nodes can be automatically promoted to the primary, minimizing downtime. Threading is MongoDB offers a flexible and powerful way to scale your database horizontally. By enabling a threading and carefully selecting an appropriate thread key, MongoDB allows you to distribute your data effectively, ensuring both high availability and efficient use of resources as our application demands grow. Scaling and scaling in MongoDB primarily involves a horizontal scalability. The horizontal scalability is an important thing to do as scaling and scaling, which allows you to expand database capacity and performance by adding more servers to the MongoDB clusters. MongoDB achieves horizontal scalability through the various techniques called threading. Before we conclude this video, we summarized what we had go through. Firstly, we started with the SQL versus non-SQL. What is SQL? Remember that structured query languages are based on predefined schema. Data is stored in the tables, and each tables have a fixed structure with the specified columns and data types. NoSQL database. NoSQL databases are the schema-less, meaning each entry is in a NoSQL database can have a different fields. They are more flexible when it comes to handling the unstructured or semi-structured data. And also remember that how to choose the SQL or non-SQL. SQL and non-SQL both are best ways to store the databases. But we choose the SQL or non-SQL based on what operations we need to do and what type of application we had to develop, and what are the things, what are the steps we need to do in the upcoming futures. It involves some of the complex operations and different unique operations based on the data. So for initially and primarily we choose SQL or non-SQL based on what are the data we use in our application. For example, for a semi-structured and unstructured data, we choose a NoSQL database. It's a good thing to do operation, can do any operations in the application via NoSQL. But when we use formatable structured data in our application, we need to use a structured query language which is called SQL. It is a very useful for structured data type. Let's see the some of the rules to choose the SQL your application requires complex queries and transactions. You need ACID, atomicity, complexity, and something stuffs compliance for data integrity. Your data structure is unlikely to change frequently. These are the conditions to select the SQL data types. For non-SQL, your application requires horizontally scalability and can be from distributed fault tolerant systems. Your data is unstructured, semi-structured rapidly, as we said 2 minutes ago. You're prioritizing high availability and can tolerate eventual consistency. And nextly, which we gone through MongoDB introductions. Some MongoDB is a popular. Let us remember that MongoDB is a popular open source NoSQL database management systems that falls under the category of document-oriented database system. It is designed to handle unstructured or semi-structured data and is well suited for building modern, scalable, and flexible applications. Modern MongoDB stores the data in JSON-like documents, making it easy to work with the data in a natural and ineffective way. Some of the key features of MongoDB or MongoDB in schema, that's it's a very important one because it make the data complexity lower the data complexity. Data is stored in a BSON binary JSON file. MongoDB is designed to scale horizontally across the large clusters of community servers or cloud environments. This allows available applications to handle large volumes of data on high traffic loads by adding more servers to the clusters. And a high availability of the MongoDB. It uses powerful aggregation frameworks. It supports a geospatial indexing, and it has a large and active community of developers and contributors for MongoDB. And also we used to see some of the different features like it supports various types of indexes. It supports dynamic queries. MongoDB supports replica sets. It can be automatically distribute data across the multiple servers nodes. It's the main advantage of the MongoDB. It uses a full text search engine. Also already we saw that it also supports a geospatial indexing. It provides a various security features like SSL and TLS encryption for data transmission and auditing. It also allows the developer to define and enforcing document validation rules. MongoDB natively stores JSON-like documents, and MongoDB official drivers were a wide range of programming languages. It supports for a wide range of programming languages. It make it so versatile. And nextly, we see in about replication and high availability. Replication and high availability are critical features in the database system to ensure the data durability, fault tolerance, and uninterrupted services. Some of the main things that supports for replication and high availability in MongoDB are replica set basics, data replications, election follower, election and followers, read scalability, data replications, data durability, and fault tolerances, automatic recovery. MongoDB replica sets features automatically resynchronization. Let us remember this. And arbiters. Arbiters are one of the unique topic. I already said. I also. It's also my duty to remember this thing again. I think in replica sets, arbiters are nodes that participated in the election process but do not to store data. They help they help in a prevent split brain scenarios where two nodes believe they are the primary by providing an odd number of nodes are voting. Replica sets in the MongoDB are robust solution for ensuring high availability, data endurance, and fault tolerance. By developing the replica sets across the different servers or cloud instances, MongoDB can provide continuous services even in the face of hardware failures, network issues, or planned maintenance activities. And finally, we saw about the threading and scaling. Threading is the most important things in the MongoDB. Threading basics, and we've seen about the key concepts as threading processes and read and write operations, adding threads, data distribution and scalability, high availability, and failover. These are the common stuffs we seen at the last 23 minutes, I think, 24 minutes, and nextly we move to the conclusions. In this conclusion, MongoDB stands as the leading solution in the world of database management system, offering a dynamic and a scalable platform for modern applications. Its flexibility and robustness and rich feature set make it a top of a choice for developers and business alike. Here are key points to highlight in your MongoDB conclusions. I need to say that MongoDB, by learning the MongoDB, it is useful in various fields. You know, for a backend developers we study some of these studies Java, some of them studies Python, C++. But it is vary across various companies and MNC companies. But when you smartly choose the database systems like SQL or non-SQL, these are topics. This is a standard for every MNC company. So I give that I give assurance, and otherwise I give a key point that it is the smart choice to pick any SQL or non-SQL to develop your career is the best option. For in this modern era, we saw that many of the unstructured data we use, like a Spotify app, it uses unstructured data, YouTube, many games, and all other stuff like of application which are so entertainment. This is some of them say this is the era of entertainment, but I will say that this is the era of entertainment. I think most of the peoples are most of the people use their free times for just for entertainments, most of the people. So for every other entertainment stuffs applications includes the non-structured data, unstructured data, non-structured data that involves no SQL. So I give the key point that you may study study this no SQL MongoDB for your better future. Thank you for watching this video. If you like this video, make subscribe, and follow me for more videos. Click your bell icon for instantly notifications, and like the video if you like the video, and if you like the video, please comment down on what are the topics to next to be covered. Thank you.